The question is like this. Find the direction cosines of the side of the triangle whose vertices are 3, 5, minus 4, minus 1, 1, 2 and minus 5, minus 5, minus 2. Okay, so the question is quite straight. We have been given the vertices of the triangle and we have to find the direction cosines of the sides of the triangle. Okay, to solve the question, we require to know the following results. First, the direction ratios of the line joining two points P and Q, P having coordinates x1, y1, z1, Q having coordinates x2, y2, z2. So these points P and Q are joined by this line segment. Okay, then the direction ratios of this line joining PQ can be written as x2 minus x1, y2 minus y1, z2 minus z1. That is the difference of x coordinates, difference of y coordinates and difference of z coordinates. Okay. Next, if L, M, N are the direction cosines and A, B, C are direction ratios of a line, then we can use these relations. L is equal to A upon under root of A square plus B square plus C square, M is equal to B upon this whole thing, and N is equal to C upon this whole thing. So we assume a triangle ABC having the vertices as the given point. Okay, so we have named the vertices as A, B and C. Okay, so now we are required to calculate the direction cosines of the side AB, BC and CA. Okay, now let the direction ratios of the side AB be A1, B1, C1. Okay, so to calculate the direction ratios, we are going to use this formula or this result, and the direction ratios A1, B1, C1 can be written as minus 1, minus 3, 1, minus 5 and 2, minus 4. Okay, which will be equal to minus 4, minus 4, 6, or dividing all three of them and writing in the simplest ratio, we are going to get this as minus 2, 3. Okay. Using the direction ratios of the side AB, that is A1, B1, C1, we are now going to calculate the direction cosines of the side AB, that is L1, M1, N1. We are going to use this formula, and L1 will be equal to A1 upon under root of A1 square, B1 square, C1 square. Similarly, M2 will be equal to P1 upon the square root of A1 square, B1 square, C1 square and so on. Okay, so this will be equal to minus 2 upon under root of minus 2 square plus minus 2 square plus 3 square. Minus 2 square is 4, minus 2 square is 4 and 3 square is 9. So we are going to get this as minus 2 upon whole this thing, and which is equal to minus 2 upon under root of 17, right? Similarly, M1 will be equal to minus 2 upon under root of 17. You can see the denominator is going to remain the same, only the numerator is going to change, and here the P1 is equal to minus 2, so we are going to get minus 2 here, and similarly N1 is equal to 3 upon under root of 17. Okay, therefore the direction cosines of the side AB are minus 2 upon under root of 17, minus 2 upon under root of 17 and 3 upon under root of 17. Now to calculate the direction ratios of side BC, we assume that it is equal to A to B to C2. Using the same formula, we are going to get A to B to C2 as minus 5 minus minus 1, minus 5 minus 1 and minus 2 minus 2. Okay, so this will be equal to this value, or on simplifying we are going to get this as minus 4, minus 6, minus 4, or minus 2, minus 3, minus 2, that is writing in the simplest form. So again, using the direction ratios of the side BC, that is the value of A to B to C2, we can write the direction cosines of the side BC, assuming that it is equal to L2 M2 N2. Using this formula again, I'm going to get L2 as equal to minus 2 upon under root of the square under root of a2 square plus b2 square plus c2 square, that is minus 2 square plus minus 3 square plus minus 2 square. Minus 2 square is 4, minus 3 square is 9, minus 2 square is 4, so which gives the value as minus 2 upon under root of 17. Similarly, m2 will be equal to minus 3 upon square root of 17, and n2 is equal to again minus 2 upon under root of 17. So this denominator is going to remain same, only this value b and c, that is b2 and c2, are going to be used here. Therefore the direction cosines of BC are minus 2 upon root 17, minus 3 upon root 17, minus 2 upon root 17. Okay, similarly for the side CA, we assume the direction ratios as A3, B3, C3. A3, B3, C3 again will be equal to the difference of x coordinates, minus 3 minus minus 5, 5 minus minus 5, minus 4 minus minus 2. And in simplest form it will be equal to 4, 5 minus 1. Again using the direction ratios of the side CA, that is A3, B3, C3, we can write the direction cosines of the side CA, that is equal to L3, M3, N3 will be equal to L3 will be equal to 4 upon square root of A3 square plus B3 square plus C3 square, that is 4 square plus 5 square plus minus 1 square, which on solving gives us 4 upon 42, 4 upon under root of 42. This value will remain same for m3 and n3, that is denominator is going to remain same. So we are going to get m3 as equal to 5 upon square root of 42, n3 as equal to minus 1 upon square root of 42. Therefore direction cosines of the side CA are 4 upon square root of 42, 5 upon square root of 42, minus 1 upon square root of 42. So direction ratios of AB, direction ratio of BC, and direction ratio of CA as calculated gives me the required answer.